Okay, so this is actually a summary notes for your electrical systems itself. So ideally, all of you should actually have tried to make a electrical system notes already, because there's a lot of definitions, there's a lot of formulas, there's a lot of calculations involved. Furthermore, there's also your practical electricity parts where there's a lot of explanations and functions to memorize itself. So what I'll actually suggest, instead of using the whole book itself, is to try to come up with a A4 paper of your summary notes itself. So knowing some students tend to not make their own set of notes, I try to make one, which is the one that you see in front of you. So first things first is your electric current itself. For those that don't remember, electric current is the symbol I. The units will be in amperes. Okay, so the first thing you want to memorize is your definition itself. This is a must memorize. Okay, then for your I is Q over T formula is not as important, because we only really use this if Q is mentioned. So which means if I don't see the letter Q, I don't see charge, I'll just write I is V over R instead. I don't use I is Q over T. So do take note about this. And the next part is ammeter is in series. Why? Because don't forget, you want to measure current, right? And if you notice, when you have a series, you have the same current. So if you want to measure the same current as your component itself, your ammeter must be in series with the component itself. All right, so do take note about this. So conventional current flow, so basically it means the default current flow will always move from positive to negative. So if and only if you see the word electron or flow of electrons itself, electrons, they are all negative charge. So if it's negative charge, what happens is we'll move from minus to plus. Okay. For EMF and potential difference itself, do take note, you need to memorize both of them. Okay, these two, you must memorize both of them. Is the work done to move a unit charge? Work done to move a unit charge by the source across the complete circuit, or between 2 points in a closed circuit itself, or across a component, both works. You notice that same thing, these two formulas itself, if and only if Q is mentioned. So if the Q is not mentioned itself, what formula do we use? We will use V equals to I times R. All right, so voltmeter is in parallel, this part below that you see here. Why? Voltmeter measures voltage, right? And parallel means same voltage across branch. So typically your voltmeter should be across only one component if you're measuring that component only. If you're measuring more than one component itself, it is for both the sum of their voltages, okay? Or if they're both parallel, then they have the same voltage. Then next, for resistance itself, the one that you want to remember, the most important one is R is V over I. Why? Because this tells you the relationship. As R increase, I decrease. As V increase, I decrease. And both of this, sorry, I will increase, right? Is basically I affects brightness. Okay, so if I have less current, I will have less brightness. If I have more current, I will have more brightness as well. So do take note, it cannot be measured. We can only use the formula to calculate it. Okay. So DC circuits itself, you can see over here. How do you know if something is a series circuit? All your components are arranged in a single path or single loop. On the other hand, parallel means all of them are in your 2 or more loops itself. So you can see down here, these are your 6 formulas itself, and don't forget to add in just the most important one. V equals to I times R. If and only if this doesn't work, then we'll use the 3. Okay? So do take note, total I means I1, I2, I3, all of them are the same, because if you were to draw your direction of your current, they'll all be the same. However, for your parallel itself, they will split into 3 parts. Okay, you have I1, I2, I3, so you can see your current the green one, is the sum of I1, I2, and I3. Okay, so you can see total I will be I1, be I2, be I3. Whereas for your series circuit, they're all the same. Okay, then for your total V itself, total V will be V1 plus V2 plus V3, but whereas for parallel, they're gonna be the same throughout. So you can kind of actually see that these two, they are opposites of each other. So you can see if series current is the same, opposite parallel must be the sum of your current. For series, voltage is the sum of them. So flip it around, your potential difference is gonna be the same. So resistance will always be different. So do take note, for resistance, we don't use this formula. We'll use the one below. We'll use this one. Okay. And for those that remember, basically each fraction represents one branch. So if my branch I have 3 branches, 3 paths to take, I will have 3 fractions. 2 paths, 2 fractions. Effective R for this one, you just add them up. Now over here, your hybrid circuits or your complex circuits itself, you can actually simplify them. What I mean by this is you can see these two are parallel to each other, right? So you can actually simplify them into basically a simple one. So your battery itself will have total current flowing through all of these parts over here. Okay, so you can simplify it, then you can find your current, you can solve for your V, you can solve for your I, you can solve for your R separately. Okay, do take note, these 6 volts is for both V1 and V2. Okay, so this is V1, this is V2 and 3. They are the same. Okay, so which means V2 and V3 are the same because they are parallel. So if you want to find V2 or if you want to find V3, you just need to take 6 volts minus V1 because these two are series. Okay, similarly, if you have a series in a parallel itself, the first thing you want to do is simplify it so that you can easily see which is which. Okay, so once you simplify it, one thing you want to take note is the entire stretch V1 and V2, these two add up to give you 5 volts. Okay, so it's V1 plus 2 is 5 volts. It's not V1 5 volts, V2 5 volts. Okay, the entire yellow color branch is 5 volts. And then this guy is 5 volts. Okay, so if you want to find your current itself, the first thing you need to ask yourself is, what is the resistance of the entire branch rather than just using 2? Because if you want to find this 2, this is R1. So which means I need V1 and I1. So you need to be careful. We don't have V1, so we cannot solve, but we do have V1 plus V2. So it's kind of like your total resistance for that branch. So branch, branch, branch. V of the branch, I of the branch, R of the branch. Must be same, same, same. Okay, do take note, the 5 volts is for the whole branch. Okay, so let's take a look at some of the work example and let's see if we can solve it. First things first, we can see that this is a 15-volt battery, right? So they want to find the current for the battery. So when you see battery itself, it means total. So they want to find total I. So if I want to find total I need total V, I need total R. So ask yourself, do we have total V? Yes, it's 15. Do we have total R? First thing, ask yourself, is this series or parallel? This is series because I just use one single loop. So 5 ohms, 5 ohms, 5 ohms. This is for R1, R2, R3. So we should end up with 1.0 current, right? Okay. See. So basically this one I actually shortcutted it. Basically I already solved what is total R, but you can actually do it as one extra step. Next, state and explain the current flowing through R1 and R2 and R3. The current flowing through the resistors are all 1.08. Why? Because the current is the same at any point in a series circuit. Or you can say that when they are arranged in series, the current across flowing through them is the same. Okay. More specifically with the battery. Okay, so because current flowing through them with the battery is the same, you can therefore conclude that this is actually the same. Okay. Now calculate the potential difference across the R1, right? So this is actually asking you for V1. So first thing you ask yourself, V1, I1, R1. Ask yourself, do I have I1? Yes. I1 we know is 1.0, right? What about R1? Let's take a look. R1 is 5, so it's 5. And now with 5.0, because we use volts, 5.0 volts. So now next is they're asking you V for both keyword. So they're asking you V2 plus 3. So V2 plus 3, you ask yourself, do we have the current of V2 plus 3? Very troublesome to find, right? So what we can do is we can just say that V2 plus V3, V1, total V, because this is series, V1, V2, V3. So if you want to find V2 plus 3, we're just going to take total V minus V1, which is just going to be 15 volts minus 5.0. So you end up with 10 volts. That's all. Okay. The next part over here, you can see this is in parallel. So parallel 1, 2, and 3. Okay. So state and explain the potential difference across each resistor. The potential difference across each resistor are or 15 volts each. The reason for that is the resistors are arranged in parallel, or you can say in a parallel arrangement. In a parallel circuit, the potential difference across each keyword branch is the same. Okay, so let me just shift it over. So determine the current flowing through R1. So first things first, current R1. You want to find I1. So first thing is I1, V1, R1. So ask yourself, do I have V1? Yes, they're all 15 volts, right? What's R1? R1 is 5. So answer is 3.0 current A. So since all of them are 3.0 current A, what's your total current? Hence or otherwise means I need to use this part, right? So I1, so I2, I3, and I1, they're all the same where you use 15 over 5, 3.08 each. So your total I will just be I1, I2, and I3. Add up, right? So it's 3.0, 3.0, 3.0. You end up with 9.0 amperes. That's it. Okay? Because your current, they are identical resistors, which means the current flowing through each of them will be the same. So you can just imagine this is 1 unit, 1 unit, 1 unit, total 3 units, right? So the current flowing through will be 3 units because these 3 units need to split 1, 2, and 3, one by one. So you can see it's just 9 amperes.